Okay, so this video, we're going to look at topic 8, section 2, statistical studies and sampling methods. So in this section, we will be able to identify experiments, sample surveys, and observational studies, recognize bias in sampling methods, and identify a sampling method that provides a random sample for a population. So the first thing that we're going to talk about are the 3 main types of studies that we will utilize in this course. And so the first type of study is a sample survey. So a sample survey is where you ask every member of a randomly selected sample the same set of questions and record the answers to try to draw a conclusion about the population. So I'm asking a question or a set of questions. An experiment involves randomly dividing the population into 2 groups, applying a different treatment to each group, and measuring the difference between the treatments. So I'm splitting up my sample, and I'm doing an experiment with 2 groups within my sample. And then an observational study is where members observe the sample in a way that they're not affected by the study. So I'm literally just observing something that is already happening, such as an animal in its natural habitat, or just the regular goings on of whatever it is that I'm interested in. So in example 1, we're identifying which type of study is shown in each of the examples. And so in A, grocery store wonders how many customers bring reusable bags to the store. So they have an employee stand at the checkout and count the number of people using reusable bags. So the thing to think about here is that the members of the sample don't even know that they're part of the sample, right? They're not engaged in the process. They aren't asked, hey, did you bring reusable bags today? It's literally just someone standing there and looking and observing whether or not these people brought reusable bags. So this would be an example of an observational study because of that. So again, the key is that they are not engaging the sample. They have no idea that they are even part of the study. So that's a kind of key to an observational study. For B, or not for B, for the next situation, a newspaper polls randomly selected residents in town about which mayoral candidate they prefer. So if we think about this, the word poll means that we're having a survey. And so this is a sample survey. Again, because the sample is engaged, I'm asking a question. So poll implies that I'm asking a question. So then finally, a doctor conducts a clinical trial of a new blood pressure medicine by prescribing it to half of the patients in the study and measuring the effects it has on their blood pressure. So they're prescribing it to just half of the patients. That means that we are conducting an experiment. Because we have divided the sample into 2 groups and given them different treatments. So one gets this medicine, it's implied that they get a placebo. So then for B, we're given questions now, and we're asked, what type of study would we use to answer this question? So how many hours per day do lions sleep? So if we think about our options, a sample survey, can I talk to lions? No. An experiment, do I need to do 2 groups and like have them one sleep and one not? No. This is going to be an observational study. And I can just see how long, wow, I cannot write, sorry. Observational study. So I can just observe the lions in the wild and record the time they spent sleeping. The next one's asking us how many students in a school would like the cafeteria to serve breakfast. So we think about this one, a sample survey would probably be the best because we're asking what they would like. So we would do a sample survey. Where we would have to ask randomly selected students and collect our data to summarize the results. Finally, we have a group of plants that is not growing well compared to the rest. What would you change to improve your growth? So this would be an idea of, if you think about like a science experiment, when you're a typical one, like the music and the light and changing those things to see how plants grow, right? So that's an experiment. And so what you could do in this case was split the plants into various groups. And provide things like more water, light, fertilizer, and compare that to the plants in their original state. So looking at these three main types of studies, we're going to move into looking at bias. So bias is when a study systematically produces results that misrepresent a population. So that means that the results of the study aren't actually true, right? And so some circumstances that can influence a result, such as the survey might have questions that influence the answer in some way, and a sample that's more likely to include a certain category of the population than another. So for example, a poll on a website is more likely to select frequent internet users than those who do not go online often. So they might not either, so those bullet points represent that like the survey or a study itself can produce bias, and in ways that it's worded or in ways that it's presented. So we're going to focus a little more on the ways that it's presented later. So for now, we're going to kind of look at the study itself, the question itself, maybe. So in the following situation, are the differences between groups potentially due to bias? So for A, we have a psychologist that's conducting surveys to study the happiness levels of people who live in a neighborhood. She asked the same questions to the two samples below, chosen from the population of the neighborhood. So the first sample is 100 people that were surveyed on a sunny Saturday afternoon. 65% of those people said that they were happy. The second sample contains 100 people who were surveyed on Monday morning. 35% of those people said that they were happy. And so we want to know, is there bias in this study somehow, right? So if these two sets of 100 people represent the same population in the same neighborhood, then they should be closer together, right? Not 65 versus 35%. And so if we think about just the nature of the circumstance of when they were asked the question, right, that can prelude to happiness. So if it's a sunny Saturday afternoon, like it's a beautiful day, it's Saturday, I don't have to work, then people are more likely to be happy than it's Monday, I'm going to work right now, and so I'm not quite as happy, or I'm going to school right now, so I'm not quite happy. So this is a situation that is likely to be biased. And again, so the circumstances of the people when they were asked may influence the responses. What we mean by that is that generally people are going to be happier on a Saturday versus a Monday. And that has nothing to do with the neighborhood. So this is likely biased because the situation in which they were asked is influencing whether or not they're happy, not necessarily the neighborhood. So then for sample B, we've got a school that wants to know the average height of its students. The school randomly chooses some students and measures their height. Some of the students are under 5 feet tall, and some are over 6 feet, 5 inches tall. So if we think about teenagers, their heights are varied. And so if I'm representing a school, is it likely that I have somebody at that school, or many people at that school that are under 5 feet tall and many people that are over 6 feet tall? Probably, right? That's something that varies naturally. And so it's okay for a random sample to contain extremes. Okay? So this is not likely biased for that reason. So heights vary naturally. So it is likely, whoops. So it is, let's just say, so it is likely for a random sample to contain extremes. Okay, so next we're going to move on to sampling methods. So how I'm choosing my sample. So in order to select a sample that is likely to be representative of the population, you need to choose members of the sample using randomness. So choosing randomly is the key in reducing bias based on just your sample selection. Right? So if I want to represent an entire high school, is it a good idea for me to only survey freshmen? No, because are there only freshmen at high school? No, there are sophomores, juniors, seniors, right? And so I need to make sure that I'm using a random method to ensure that I'm getting this result that represents the population better. So the simplest way to use randomness, because each member of the population is equally likely to be chosen, and each possible sample size you want is equally chosen. So a simple random sample literally means, think about it like drawing out of a hat. So I have everybody's name in the population, and I just draw the names, right? So that's a simple random sample, okay? And so that's the most basic kind of a sample, and it's the simplest way, again, to make it random. So then some other sampling methods that involve randomness are listed below. And we're thinking about this kind of on a continuum or in categories. So these three on the left have less likely or less likely to be biased. And then the ones on the right are more likely to be biased. And so that's what this is. Care must be taken to avoid bias represents that. These can still be biased, but they're less likely to. So the first type is a stratified sampling. I'm just going to underline these names because of the definitions here, but it's not really bolded. So stratified sampling is when a population is divided into groups with similar characteristics. And so, and the sample is randomly chosen from each group. So notice that I have two different groups. So the population is divided into groups, so divided in half. And then I'm selecting a random set of the population from each group. So I'm going to highlight. I know that if you're using this printed out that's not colored, you need some way to kind of show what your sample is. So I divided it into groups, and then I highlighted the people that were selected randomly. Cluster sampling and stratified sampling are similar. And so the way that they're different is that when I'm doing cluster sampling, is I'm still dividing that population into groups or clusters. So it's still divided, right? This was divided. And so if I have these 3 groups here, the difference is that entire clusters are selected. So I select that whole group. Okay. So if I'm thinking about representing a high school, right? So a stratified sample would be that I divide everybody into freshmen, sophomore, junior, senior, and I take 30 freshmen, 30 sophomores, 30 juniors, 30 seniors, right? And then a cluster sampling would be that I just take all the juniors and I say, cool, this is my sample. Okay, so we can see why care must be taken to avoid bias, because if I want to represent the whole high school, we already talked about, it's not a good idea to just take one grade level. Okay, and so in that situation where we're talking about a school as a whole, then a cluster sampling is not a good idea. But if I were to take clusters like all high schools in California, and here is all the high schools in each county, and I pick one county, that would be an okay way to do a cluster sampling, because that county still holds all the kids at every grade level. Systematic sampling is when you start with one member chosen at random. Usually, like if we were to think about this as if I were to look at your ID numbers, right? So if I select one person and I start at that person, and then I pick every 20th student at the school after that, going by ID numbers, right? And so in this case, I'm starting by choosing this person first. Oops, didn't get the highlighter. I'm choosing this unit, this member first, and then I'm counting 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and I'm selecting people that way. So that's a systematic sampling. Convenience sampling is only choosing subjects that are in close proximity or easy to get to. And so that would be where you're just asking your friends, right? So if I'm just asking my friends, because I talk to them every day, I can ask them this question, or I can survey them for whatever my experiment is, then that is a convenience sample. So I'm looking at people who are alike in some way because they're close to me, right? And so there must be some connection between them that makes them not necessarily a diverse group, right? You get along because you have similar opinions on things. So that would be a convenience sampling. The next is self-selected sampling. They might call it volunteer sample too. So the way that this one is that these people are saying, I will participate, right? I would like to be a part of your study. So they're selecting themselves and saying, here, I will do this. So in the next set of problems, we're going to look at what type of sampling method is used, and then we'll go into a little bit more on experiments. So for example 3, what sampling method is used in the following examples, and is the method likely to be biased? So really our answer to the second question just comes from here, right? So if it's one of these, so if it's simple random, stratified, cluster, or systematic, it's not likely to be biased. And if it's convenience or self-selected, then it's likely to be biased. So starting with a randomly chosen ID number, every 5th student ID number is chosen, and that student was asked to fill out a survey. And so this is a systematic, because we're looking at every 5th, right? That's our rule. And so this is not likely to be biased. A retailer put feedback cards at the front of its store. So a feedback card is something that I'm volunteering to choose to fill out, right? This is something that is self-selected. You can think about this as like when you get the surveys at your receipts, right? That's a self-selected survey. This is likely to be biased. Ultimately, you're going to fill out feedback if you know the cashier and you want to give them, that they get something if they get a positive note, or if you had a really bad experience and you want to complain about it, right? That's when you're more likely to fill out a feedback. So they got responses from 22% of their customers in that situation. The last one here is that the city wants to know what percent of people in the city own a dog or cat. A city worker goes door to door in a neighborhood around the city hall to ask people about their pets. So ultimately, we could think about this as a cluster because they're just choosing one neighborhood. But the key here is that it is around City Hall. And so that means that it's close in proximity, right? So when it's close in proximity, that is something that is convenience, which is likely to be biased. I don't think I answered that for the last one. Oh, I did. Okay. So again, it could have been interpreted as a cluster because it's in one neighborhood, they're asking everybody, right? But the fact that it was around City Hall makes it more of a convenient sample. And so that makes it to be likely biased because it's near City Hall where they work. Finally, we're gonna look at a simple controlled experiment. So simple controlled experiment is when researchers use statistics to compare the effects of a treatment to the effect of no treatment. So to do this, subjects are randomly assigned to one of two groups, either the experimental group, the ones that receive the treatment, or the control group, subjects that do not receive the treatment. So some experiments can have more than two groups, especially if you're testing multiple variables. Some experiments do not have a control group and just compare different treatments. So they could each be getting a different treatment and you're comparing how those treatments do versus each other as opposed to how they do against nothing. So in this last example, we're just describing a design for a controlled experiment to test a new drug treating the flu on mice. And so how does randomization apply to your design? So ultimately, what we're doing is we're dividing, we need to divide the mice into two groups. So the first group is that experimental group. And so the experimental group is the one that receives the new drug. And the control group is the one that does not receive the new drug. So if we're testing these drugs on animals, what we're doing is we're taking the mice and randomly assigning them to a group. All mice need to have the flu. And then we compare the results of the progression. Okay, so again, notice that everything was vocab here. So we're looking at understanding those different terms. When we talked about the 3 different types of studies. We talked about bias. We talked about sampling methods. And so remember that we talked about 6 different sampling methods. So the first one was simple random. Then we talked about stratified. Then we talked about cluster, systematic, convenience, and self-selected. So you need to know all 6 of them. And again, making flashcards might be a good idea if you're bad at memorizing things, writing down each of those definitions. And then we talked about that the first 4 are less biased and that the 5 and 6, convenience and self-selected or volunteer, are the most likely to have bias. And then finally, we just talked about a simple experiment where we have an experimental group that does not receive, or sorry, that receives the treatment and a control group that does not.